Okay, grade 9s, we're moving on to 4.2 today. 4.1 we looked at enlargements and reductions, and then in 4.2 we're going to actually use enlargements or reductions, or in other words similar shapes, to do two things. We're either going to predict the missing side length or width, or we're going to use the length of two different shapes that have been either enlarged or reduced, and say what scale factor was used in between those two shapes. So there's two main examples that we'll go through, one doing the one skill, the other one doing the other skill. Okay, so example 1 here, this is a typical question, and the skills that we need to use, we practice a lot in grade 8, cross multiplying and dividing. And so just keeping things straight in a ratio or in a fraction, we can set these up and solve them pretty easily actually. So it says a scale diagram of a skateboard uses a scale of 1 to 14. So that means that on the picture or on the diagram, compared to the actual size of the board, that's what this ratio means. So 1 to 14 just means on the diagram, the actual board is going to be 14 times as big as it is on in the picture. Okay, so then what the types of questions you'll have to do is just like this, where they give you the length of the skateboard. So what is the actual length of the skateboard? Well, on the picture, it's telling us it's 5.5. So the reason I actually label this is so that you keep it straight. Diagram to actual. So if this is diagram to actual, what am I given here? Well, it's the diagram, 5.5. And so actual, that's going to be my missing variable. So we can set it up as a ratio, and we can do a skill that we've done a ton in grade 8. We can cross multiply and divide. So the actual skateboard is just going to be 5.5 times 14, and in this case divide by 1, but that's not going to actually change my answer in any way. So I can just do 5.5 times 14 to calculate my answer. I think this is by far the easiest way. Students typically prefer doing the cross multiply and divide way. I like it as well because as long as you set it up properly and you have diagram, actual, you can't mess it up. You just cross multiply and divide. So the actual size in this case would be 77 centimeters. Okay. So similar example here to work through. The scale for the diagram of a Chinook salmon is 1 to 9.2. So again, we've got a similar situation, diagram to actual. So if on the picture it's 1 centimeter or meter or whatever it happens to be, the units don't actually matter. It's 9.2 times as big in real life. That's what this is saying, diagram to actual. So again, I've got a diagram that's telling me this fish is 5. So I'm putting diagram on this side, and my variable is what's missing. And so all I have to do then is cross, multiply, and divide and get my missing number. So then the actual size of the fish is 5 times 9.2, divide by 1, but that won't do anything to the answer. 5 times 9.2 gives you 46. Okay, so then the answer is the actual salmon is 46 centimeters. All right? So that's going from using the scale factor in one other dimension to find the missing dimension. In the last examples here, we'll look at actually finding the scale factor. If you have two similar shapes, what is the scale factor? So an actual Canadian quarter has a diameter of 23.88 millimeters. So 23.88 millimeters. Now this question in the book, if you look in the book, the only way I could do this question to figure out the scale factor is to actually measure this. And I've clearly enlarged it, but I'll just give you what I measured it, and you can do it at home too. You can look in your book, you can measure it and find that it's 1.4 centimeters across in your book. Now we run into a couple problems. Well, the main problem here is that it's a different unit. So you kind of actually want to measure this in millimeters, which you could do easily. Just change that to 14 millimeters across in the book. And then an actual quarter has 23.88 millimeters as a diameter. Okay, so if I go from one to the other to find the scale factor, I'm just going to take the bigger number and divide by the smaller number. I don't really need the units for that. Okay, so 23.88 divided by 14. So that gives me kind of a scale factor of 1.71 if I round it. Now, this is where kind of some common sense comes into play. If I just think of this as a scale factor of 1.71, that means going from the smaller one to the bigger one, I need to multiply by 1.71. If I was going from the bigger one to the smaller one, then I would be dividing by 1.71. So you actually could also do the scale factor the exact opposite way. You could do 14 divided by 23.88, and that'll give you kind of going from the big one to the smaller one. So 14 divided by 23.88 gives you a different scale factor. Now, both of these answers for me are going to be acceptable. I don't really mind you doing either way, as long as you keep straight. What does that actually mean, a scale factor of 0.59? That means if you're taking the actual, you're multiplying it by 0.59 to get to the smaller one. This one, you're taking the smaller one and you're multiplying by 1.71 to get to the bigger one. So as long as you know what you're doing for the scale factor, you can do it either way. I always prefer just do the bigger number divided by the smaller one, because I prefer getting a scale factor that's bigger than 1, but that's just a preference thing. So it's totally up to you how you want to do these. Okay, we'll go through the last show you know here. It says the flying distance from Dawson City to Whitehorse is 540 kilometers. That's an actual distance. The distance on the map is just 3 centimeters. So again, we're going to set this up as a ratio, map to actual. So on the map, it's 3 centimeters. Actual is 540 kilometers. Okay. And so we can do A, complete the following to express the map scale in words. 1 centimeter represents how many kilometers? Well, I can just plug this in as 1 centimeter equals what? And I can do the cross, multiply, and divide method. 540 divided by 3 will give me how much 1 centimeter equals in kilometers. 540 divided by 3 equals 180 kilometers. Okay, so 1 centimeter on the map represents 180. And so what's the actual scale factor? Now this we do have to be careful with, because we're basically finding in A that 1 centimeter is 180 kilometers, but that's not actually an accurate scale factor. We can't say the scale factor is 180 times as big, because it's actually far more, because we have to convert a centimeter into a kilometer. So it's actually a far greater number. And so the way we do this is we actually use this conversion. They tell us that 1 kilometer equals 100,000 centimeters. So 180 kilometers, you could also just kind of work your way through it. If you know that a kilometer is 1,000 meters, you could take 180 times 1,000. Okay, that'll give you the answer in meters. And then there's 100 centimeters in a meter. So 180. Shouldn't really need a calculator for that, but and then times that new answer by 100 centimeters. You could do it all in one shot if you just use that as well. So basically we just need to add a couple zeros. Okay, so what that means is basically 1 centimeter on the map equals 18 million centimeters in real life. So the scale factor, you could just write the scale factor as 18 million. Okay, and that makes sense, because if you travel somewhere that's a few hundred kilometers away, you know that's a lot of little centimeters that are added up together. So this makes a little more sense than 180 for this example. Okay, so you have a few questions to practice on page 143.